Okay, fourth and last example for implicit differentiation. I just want to remind you that all four of these, I did them out on paper and I uploaded them to Google Classroom. So not only am I doing them out on the whiteboard for you in the video, you also have them on Google Classroom all done out on paper in case you want to look at them step by step on paper. All right, so for this particular problem, you're multiplying the x and the y underneath the radical. So you can actually rewrite this as x to the 1/2 y to the 1/2 equals x minus 2y. So now we have to take the derivative of all three terms. But again, just like the last one, this x to the 1/2 y to the 1/2 is product rule. So I want you to think of this as a times b. I'm not going to write the whole thing out again. But you know, using the product rule, you have to do a prime times b and then plus a times b prime. All right, so if we do a prime b, we have to take the derivative of x to the 1/2. So we get 1/2 x to the negative 1/2 power. So there's a prime times b, y to the 1/2, and we just took the derivative of x with respect to x, so this term is dx. Bring down your plus sign. Now we have to do a times b prime, so x to the 1/2 power times the derivative of y to the 1/2, so we get 1/2 y to the negative 1/2 power, and we took the derivative of y with respect to x, so we have dy dx. That equals the derivative of 1x to the first power is just going to be 1, dx minus, and the derivative of 2y is just going to be 2, but this one's dy dx. All right, so we're going to get rid of the dx's, and we're going to clean this up at the same time. So here's a dx, here's a dx. So let's just get rid of those and clean this up. So we end up with 1/2 x to the negative 1/2 y to the 1/2 plus, now let's clean this up. I'm going to put the 1/2 in front, x to the 1/2 power y to the negative 1/2 power dy dx equals 1 minus 2 dy dx. All right, so here's where I want you guys to pay attention. Listen very carefully. All right, we have fractions, yuck. We also have negative exponents. Don't change anything. Let's get rid of them. So keep in mind, whenever you have an equation, as long as you multiply the left side or do to the left side what the same thing that you do to the right side, just keep it balanced, you can do anything you want. You can add, subtract, multiply, divide, as long as you do the same thing to both sides. So here is my suggestion. We're going to get rid of fractions and we're going to get rid of negative exponents. We are going to take the whole entire equation, and in order to get rid of the 1/2s, we can multiply everything by 2. Now, to get rid of x to the negative 1/2, I can multiply by x to the positive 1/2. And in order to get rid of y to the negative 1/2, I can multiply by y to the positive 1/2 power. We're actually going to take 2x to the 1/2 y to the 1/2 and distribute it to all 4 terms in this equation. Okay. So let's look at these two. I'm going to multiply 2 times 1/2 and I get 1. I'm not even going to write the 1, but 2 times 1/2 is 1. X to the 1/2 times x to the negative 1/2 would give me x to the 0. And you guys know anything to the 0 power is 1. And then y to the 1/2 times y to the 1/2, if you add the exponents, 1/2 plus 1/2 is 1. We get y to the first. There's our first term. Bring down the plus sign. I'm going to multiply these two terms. 2 times 1/2 is 1. X to the 1/2 times x to the 1/2 is x to the first power. Y to the 1/2 times y to the negative 1/2 gives me y to the 0 power, which is just 1. And now I have to include the dy dx. Bring down your equal sign. 2x to the 1/2 y to the 1/2 times 1 is just 2x to the 1/2 y to the 1/2. Bring down your minus sign. And then 2x to the 1/2 y to the 1/2 times 2 is going to be 4x to the 1/2 y to the 1/2. And don't forget the dy dx. All right, so we've gotten rid of fractions and we have gotten rid of the negative exponents. So the next thing that I need to do is take the terms that contain dy dx, get them together on one side, get the other terms on the other side. All right, so I'm going to leave this x dy dx on one side, x dy dx on this side. And I'm going to add 4x to the 1/2 y to the 1/2 dy dx. That equals 2x to the 1/2 y to the 1/2 minus this y. All right, so the terms that have dy dx are together on one side. And again, just like the last one, I'm running out of room. So I'm going to erase the dy dx and factor that out. So we have dy dx out here. So in order to get dy dx by itself, we can divide both sides by x plus 4x to the 1/2 y to the 1/2. So we get dy dx, our derivative is this, 2x to the 1/2 y to the 1/2 minus y, all over this quantity x plus 4x to the 1/2 y to the 1/2. And then the last step, we're going to clean this up. You have 2x to the 1/2 y to the 1/2. You guys know the 1/2 power is the same as the square root. So I'm going to change this term right here to 2 square root of xy. And then bring the minus y. And then I'm going to do the same thing in the denominator. I have x plus 4x to the 1/2 y to the 1/2. So I'm going to write 4 square root of xy. So that is your final answer for the derivative using implicit differentiation. So just make sure you take these 1/2 powers and clean them up, change them back to square roots. And again, I know this is messy. There's a lot going on this whiteboard. I'm just going to remind you, all of these steps are actually written out line by line and uploaded to Google Classroom so that you can see them a lot nicer than on this whiteboard. That's it.